Welcome to my demonstration. I'm Massimiliano Salsi. Today we'll talk of mode division multiplexing for high capacity. The context of this demonstration are optical transport networks, talking about submarine networks, terrestrial networks. In general, in all these networks, we have to satisfy an always increasing traffic demand. To do this, researchers have always provided new solutions. We have seen in the past that technologies like wavelength division multiplexing have provided a great system capacity increase, and today our product, the 100G coherent transponder, uses polarization division multiplexing as well and provide an even greater system capacity. But how can we continue to increase this capacity? We need to provide even new solutions, like, for example, the object of this demonstration, spatial division multiplexing. So we have always used up to now different properties of light: power, phase, polarization, and wavelength. And there's one property that has never been used before, which is the space. We can do space division multiplexing, or in particular mode division multiplexing. I will try to explain you this concept. The fiber is a guiding structure, and it supports different modes. The modes are the solution of the propagation equation. On the contrary of a single mode fiber, we use a few mode fibers that support up to 6 modes, and we are able to master the information of each one of these modes in a well-defined way, so that the capacity of the single fiber is multiplied by the number of modes. This is just the concept. Let me show to you the practical realization. In this laboratory, we have a channel at 100 gigabit per second that enters a mode multiplexer and mode converters based on phase plates realized by Bell Labs. The channel is transmitted over the fundamental mode, and the delayed version of it are transmitted over the higher order modes like LP11 and LP21 through 40 kilometers of few mode fibers. And then at the receiver we have an analog structure that is symmetric with respect to this one, that demultiplex the signals, and we have coherent receivers, analog to digital converters, and a DSP that are capable to detect not only the fundamental mode but also the higher order mode, with a specific DSP for the degenerate cases that transport 200 gigabit per second. So in this way we can transport 500 gigabit per second by using the bandwidth of just one channel, and we have presented this transmission at the ECO conference too. Now let me show you the experimental setup. This is the mode multiplexer, and there you cannot see it because they are in the infrared, but you have optical beams that are coupled and goes into the few mode fibers. The beams are blocked by this carton. They have this shape because they go through these phase masks, and they are spatially modulated. So in this case, I'm opening the way to all this beam, and we are transmitting these 5 modes into the fiber. So these are the total modes transmitted, and I can block all the beams one by one to reduce the total capacity of the fiber. But it's better if I increase the capacity. Taking away. And you can also try to, but that's quite difficult to see, try to look at the infrared camera when we have just one optical beam. It's very slow, so let's wait for the image to be stable. This is the LP11A mode, and now I put the LP11B mode, which is 90 degree with respect to the first one. These are 2 higher order modes, and I can also show you this LP21 mode, which is 4 lobes.